Recently I got an Arduino, which, as you may or may not know, is a small microcontroller that you can connect to a PC and then you can program it to do all sorts of interesting things. And since it's almost Christmas, I thought it'd be a nice idea to use it to build some sort of automated Christmas lighting system. So the plan was to create a lighting system that would adjust itself to the environment that it's in. So that would mean that the lighting system would look at the environment and would then determine what kind of colour it would need to have to fit into that environment a bit better. So for example, in this environment that is rather brown and warm looking, the lighting would then adjust itself to be a bit warmer and more brownish itself to fit into that environment better. Now for the lighting I ended up using a little transparent plastic snowman that I had laying around from some other Christmas light thingy. So what I've ended up making is basically an RGB snowman that adapts itself to the environment, and it's pretty cool. So here's a little demonstration of what it does. So this is what our Christmas lighting setup looks like. So first of all, we've got an Arduino microcontroller which is connected to this snowman. Ooh, careful with that snowman. The snowman has an RGB LED down there. So that is actually is not an RGB LED, it's 3 separate LEDs. One's red, one's green and one's blue, and they're connected to 3 different pins on the Arduino's output. The Arduino is also connected to a computer through this USB cable right here. Then we've also got this webcam. Now this webcam is observing the environment. This has the job of looking at the environment and determining what the colour of the snowman is going to be. So you can see the video feed from that webcam goes into the computer and you see it on the screen right now. Okay, so that's the video feed of our webcam. Now what I'll be able to do is I can simply go over to my keyboard and I can press enter, and then if everything goes to plan, the snowman should light up kind of orange brownish because that's the colour of the roof. So here we go. So now the computer performs some processing, so it can take a little while. There you go. As you can see, I'm not too sure how well you can see the colour on camera, but it's kind of red orange-ish, which is kind of the colour of this roof that our webcam is pointing at. This system has 3 stages. The first stage is observing the environment. This is essential because how can the Christmas light or how can the snowman adapt its colour if it doesn't know what the colours of the environment are? So this is the first step and perhaps the most important step, and it involves the webcam that we just saw. So the webcam films the environment and sends a video feed into the computer. The second stage is to take this information that comes from the webcam and process it in some way to figure out what the colour of the Christmas lighting should be. And then the final stage is to take this colour, this advised colour that comes out of the second stage, and then make the Christmas lighting have that colour. So it all starts off with this simple Windows batch script. So that's simply a script that runs in the Windows command line, and that command line window is running on a different monitor. So when this snowman system is in use, this is opened up as a command line instance on some other screen, or maybe it's minimized or whatever. Now, what you can see is that the first thing that this script does is it tells the user, press enter to adjust Christmas light colour, okay, and then there is a pause. Now what this basically means is it waits for the user to press a key. So if we press enter, it'll continue, but it will also continue if we press any other key, actually. Now then, we get to this first line, okay, and this line says that it should execute this program called cmdcapture.exe. Now cmdcapture.exe is a screenshot program that runs directly from the command line. So as soon as you start this program, it immediately takes a screenshot of your primary monitor. And you have to realise that while this script is running, remember, on the primary monitor, that's where our video feed is from the camera. So what happens is it takes a screenshot of that video feed, and it then stores that screenshot in this folder, and it calls it screenshot.bmp. Now you might be wondering, why do you use a screenshot of the video feed instead of just taking a picture with the Windows camera, right? Why don't you directly record the image instead of like taking this screenshot of the video feed? Why is that? Well, first of all, I need to be able to automate it, and I couldn't find a way of taking a picture from that video feed through the command line entirely. And also, I couldn't find any program that would store an image as a bitmap, which I need for the next step of the entire system. So therefore I'm using this screenshot method. Also, I've set the resolution of the primary monitor to 720p when this system is in use, so that my screenshot is 720p, because then the processing is much faster. The next thing this batch script will do is it will execute this program, imageprocessor.exe. Now that is a program that I wrote myself using C#. So now let's go ahead and take a look at the source code of that program. So I've opened it up here. So it starts off by importing this image that we've stored, right? So remember, this path right here is the same path specified to the CMD capture utility. So this program opens the screenshot, the bitmap image of the screenshot, and then it initializes a bunch of variables, okay? Now then there is this for loop structure right here. So as you can see, we've got a for loop, and inside that for loop is another for loop. And what that does is the following. This for loop runs through the pixels of the image vertically, and this for loop runs through the pixels of the image horizontally. That's what we're doing with these for loops. Now there is something curious about those, and that is that we're not incrementing per pixel, we're incrementing per 4 pixels. So we're skipping 3 pixels every time. And there is a good reason for that, which is if we don't do this, it takes multiple minutes to process the image. It takes way too much time to run through all of the pixels in a 720p image. Even with 720p potato mode engaged, it still takes too long. So I'm incrementing by 4 to solve that problem. Now for every one of these pixels, you can see what we're doing to it here. We get the color of the pixel, and we get its red value, which we store, and its green value, which we also store, and its blue value, which we also store. And then what we do is we add that value up to a sum value, and we do that for green and blue as well. So what we're basically doing is adding up all of the red from all of the pixels, and all of the green from all of the pixels, and all of the blue from all of the pixels. So after we've run through the entire image, we get a massive amount of red, a massive amount of green, and a massive amount of blue. And we divide those amounts by the amount of pixels that we've processed, and that gives us an average red, an average green, and an average blue value for our image. And that is the color that we want the snowman to have, right? That's the average color of the environment, and the snowman in this case needs to match the environment, so this is the color we want. So then it simply just prints out those values in the console so that I can see if everything goes well. And then the next step begins, and that is transmitting this data to the Arduino, because of course that needs to happen too. The Arduino needs to know this color so that it can adjust the color of the lighting inside the snowman. So what we do is we initialize the serial port, which is called COM3, which is the port that the Arduino is connected to. We set up some more things here, and then we open the port, and then we store the red value that we got here, the average red value, into 1 byte of information. Now that is possible because an RGB value, a red, green or blue value, ranges from 0 to 255, which means it can be stored in exactly 1 byte of information. So this is very convenient. We then proceed to send that byte to the Arduino, and then we wait. This line here says that we wait for a response from the Arduino. We wait for anything to come back, because that confirms that the Arduino received our information. You'll see more about that later on. Then we just print out message received on the screen to confirm that everything is well. And then we do the same thing for green and for blue. And then, if everything has gone right, the Arduino has all of the information that it needs to adjust the light colour of that snowman. Alright then, so now let's see what the code looks like that is running on the Arduino. So here is the Arduino IDE. And you can see that we start off by, let's get this out of the way, initializing a couple of variables. So first of all, we initialize a variable called transmitted value. Wait, what is that? That doesn't look very good. There, transmitted value, which is just set to 0 for now. We also initialize an array. Okay, also int doesn't mean initialize, by the way, it's integer. It means a whole number. So we also initialize an array of 3 numbers. Color array. Okay, this is where we're going to store the red value, the green value, and the blue value. So we'll put them in this array of 3 numbers. And finally, we have an integer I, which is 0. You see what that does later on. Then we proceed by setting up the serial communication and initializing the I/O of the Arduino. And now comes the interesting part. So first of all, we perform a serial.read, and we assign that value to transmitted value. Right? So transmitted value is now 0, but it will be changed to whatever comes in through USB. So whatever comes in through the USB cable will now be assigned to this variable. Then we check if the transmitted value is bigger than 1. If it is, then we proceed, which it usually is in an RGB situation, because a red, green or blue value lower than 1 is very unusual. And if it is, we store that value into the I index of the color array. Now remember that I is now set to 0, so index 0 in the array will be the transmitted value. Since red is the first one that it receives from the C# program, that means red will be in the first index of the color array. Then what it will do is it will add up 1 to variable I. So variable I used to be 0, now it becomes 0 plus 1 is 1. Next, it will print, OK, I got it, in the serial link. So what this means is that the Arduino will send a message to the computer through the USB cable saying, OK, I got it. And this, I figured it would be quite funny, because when people are talking about computer science and computers that are, sending data to each other, they're often comparing it to human conversations, and they're using examples that computers say things like, OK, I got it, and hey, I've got something for you, that sort of thing. But in this case, the Arduino actually sends the human message, OK, I got it, to the computer. It actually sends this as a text string to the PC. And the PC, remember, in the C# script, when it receives anything, so it doesn't matter what we send, it'll proceed, and it will say message received, and it'll go on, etc. Then, what it will do is it'll write this data to one of the pins. So what it will do is color array 1, index 1, well that's just 0 at the moment, so is 2, but 0, wait, it's just assigned a value to that index, and that's the value of red. So the value of the red channel will be written to pin number 6, and that happens to be the pin to which I have connected my red LED, obviously. And it will do the same thing for blue and the same thing for green, and that's how our 3 channels get adjusted properly and the snowman gets the right colour. Well anyway, that's how this incredibly overcomplicated RGB snowman works. I hope you've enjoyed this video, and of course, thank you for watching.